Why settle for ordinary lessons? Discover a smarter, easier way to learn. This is Muto Online. Get instant access to notes, past papers, and scenario-solved lessons, all tailored for competence-based curriculum.
Whether it's UNEB prep or just extra practice, we're here to make learning fun and easy. Subscribe now and let's ace those exams together. Show you how to get the best.
This is Teacher Alan representing Muto Online. We are going to start topical sessions. We are going to start covering topics. And this marks the first video for the first topic. And we are making a playlist that has all the explained notes about this topic. I'm going to have a look at chemistry. And specifically a topic called oxidation and reduction reactions. This is the topic I want us to cover. And under this topic, in this video, by the end of it, we are going to make sure that we have given, so this is our lesson outline for this video. By the end of this video, we are going to make sure that we have looked at, we've introduced the topic. We are going to make sure that we define key terms in the topic. And we are going to make sure that we look at what we call oxidation states so that we can understand better, or oxidation numbers, so that we can understand better the next session. Remember, we should always not forget to subscribe where necessary, comment, share the videos if you really like what we do. Like. It's simply clicking that thumb pointing up. I would like us to look at this topic, oxidation, reduction, reaction. I am sure that all of us, if not mistaken, you've ever come up across a raw mango. You have ever seen an apple. You have ever seen a raw avocado. When you happen to cut an avocado when it is raw, before it is ripened, and expose it to air for some time, we shall find that there is change in color of its seed. When you cut an apple and expose it to air for some time, we shall find out that the apple changes from whichever color of the cut surface, usually gray, to brown. The same applies to the mango, raw mango. All of these define oxidation. We've ever left, or we've ever came across and sheets left outside in moist air. They usually change color. They change color because of these reactions. We are going to realize that by the end of this topic, when you happen to watch all the videos in this playlist, you're going to realize that oxidation and reduction are widely applied in our daily life, whether known or not. We are going to find that we are only surviving on these two reactions, oxidation and reduction reactions. Members, I'll go to the next lesson outline where we shall define the key terms. We are saying that oxidation itself is one of the terms. I'm sure when we look at this word oxidation, something comes to our mind. We are looking at it when you look at the word oxidation, there's this part of ox. I think it is relating something common to you. And I'm going to find that oxidation is any reaction that involves addition of oxygen. And remember, where oxygen is in these reactions, hydrogen doesn't exist. Removal of hydrogen. We are going to also find that oxidation can also be defined as loss of electrons by any reacting atom or molecule, and usually an increase in oxidation states. So, as you define, as you give any reason for any scenario, if they tell you to categorize any reaction as either, as a redox reaction, for you to define, to give the category as an oxidation reaction, one of these ones should be reflected in the scenario, or in the equation, or in any reaction described in the scenario. There should either be addition of oxygen to any substance. There should either be removal of hydrogen from anything, or there should always be loss of electrons. And usually, all these three results into an increase in oxidation states or oxidation numbers. We are going to find another term, reduction. Members, this term, reduction, is an opposite of oxidation. We are going to find that reduction is simply addition. The other time we are adding oxygen. This time there's going to be addition of hydrogen. So any reaction described as adding hydrogen, described as removal of oxygen from any substance, gaining of electrons, by any substance, or decrease in oxidation states or number, will always define reduction. So remember, any reaction described in whichever scenario or task they will give you, described by either addition of hydrogen, removal of oxygen, or any reaction that involves gain of electrons, that will be defined as gain of electrons by any substance or decrease in oxidation states will always be what we call a reduction reaction. Members, remember, don't forget to watch other videos in this playlist. There are a number of them. When you watch one, it will direct you to the next. When you watch one and don't watch others, you will not get the concept of the topic. This is video one, where we are looking at these lesson outlines. We shall also find some reactions where both oxidation and reduction occur simultaneously. As this one is reduced, the other one is oxidized. Such reactions, we shall always define them as redox reactions. So there will be reactions. There are always going to be reactions that involve oxidation and reduction occurring simultaneously in a reaction. So any reaction that will involve the two, shall look at them. We are going to see them. We are going to talk about the oxidation reactions. We are going to talk about reduction reactions. We are going to talk about redox reactions one by one. And you are going to find them down in the playlists. So this one is strictly looking at this one, the introductory part. We are also going to look at, we are seeing another term, oxidation. Oxidation state or number. We are also going to look at that. So, an oxidation state is simply going to be the total number of electrons and atom or ion needs to gain or lose so as to form a bond. What we call oxidation number of any substance, the oxidation state of any substance will always be the total number of electrons an atom or an ion needs to either gain or lose so that it can form a bond. We can calculate these ones and their principles we follow. I wanted us to know these ones, to learn how to calculate for the oxidation states first, because they are going to help us understand better these reactions. So it's better we learn how to calculate them first. Continue. There are principles we are going to follow when calculating for oxidation states. So we are looking at the principles found when